In this lesson we will learn how to measure things like a real chemist. We're going to learn how to show the correct accuracy and the correct precision in our measurement. Every measurement instrument, as you can read, has an intrinsic level of precision. Whenever you use it, it can tell you certain things and it can not tell you certain other things. Depends on the device. If something is calibrated in big chunks, then you can't get very much precision. If it's calibrated in small chunks, you can get more information out of it. You can get a higher precision. The smaller the chunk you can measure with, the more precise your measuring tool, the better measurement you can make. If you buy a graduated cylinder with a whole bunch of measurements on it, a whole bunch of marks on it, it's actually going to be more expensive than a graduated cylinder with just a few marks on it. And the higher the degree of precision, the more information you can make with a measuring tool, the more expensive it's going to be, the more information you get off of it. What am I talking about? Well, let's first go through the rules and then we'll look at some different measuring devices. How to measure. First thing that you do when measuring is you readily measure whatever information you can get by the measuring tool that you're using. We'll see what I mean by that in a second. And then, once you've exhausted all the information that you can actually measure, you then estimate one more digit. Estimate. Estimate doesn't mean to guess, it means to estimate. It means to look at what the device is showing you and come up with a reasonable sort of number that it may not read off of the device, but it can be inferred from the device. We'll see what I mean. We really got to work some examples, which we'll do in a second. And finally, always remember to read the instrument and then use one more digit of estimate. If you give more digits than that or fewer digits than that, then you've actually measured incorrectly. You've either shown too little or too much precision. So let's look and see what I'm talking about. Here is a red line. I wish to ascertain the length of the red line. Now I have two different measuring devices. I have a cheap one that only has 12 marks on it, and I have an expensive one that might have, this has 150 marks on it. I can obviously get a lot more information out of this thing. It has much smaller marks on it. I'm going to use the metric side here. These are both centimeters. This is marked out in centimeters and this is marked out in centimeters. But this one also has smaller marks between the centimeters. If we compare the two, we can see that this it lines up. The 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They're both centimeters, but the one on the bottom has 12 marks between each centimeter, so you can actually further measure to the 10th of a centimeter, aka the millimeter. So these two lines that I have here are identical lines. I cloned them with the program, and so I'm going to put this up here and I'm going to measure the length of it using the rules that I just described. And so we get the left edge lined up exactly with the edge of that ruler, and then we look at the right edge and we're going to measure that, and we'll do the same down here with the other guy. Measure out there, get lined up perfectly. So I have a little magnifier here that I can get out. If I want to, I can look real closely. So we'll bring that back in a minute. So let's look up here. On the top, we have the red line is between the 10 and the 11. So when we look at that, we say we can make the measurement when we go back to the part that says measure what you can with the device readily. Well, we know it's between 10 and 11, so we know we can write 10. That's 10 is a measured number. We know that it is 10. What we don't know is what's next. Clearly it's bigger than 10, though. We shouldn't just write 10. Nor should we say 11, because it is between 10 and 11. It is bigger than 10 and it is less than 11. So we know that the number is between 10 and 11, so it's 10.2, 10.3, 10.5. What is it? Well, we don't know. The actual device doesn't tell us that. And that's what I mean whenever I say that we need to estimate. We've got to estimate one digit. So what we've got to do now is we've got to look and we've got to estimate Well, about where is that 10? Is it 10.5? Is it 10.7? What is it? So what I'm going to do is I'm going to look, and I'm going to bring this extra little line in to help us kind of line it up. If I put that in there, I can now kind of use that as a guide. How far is that between the 10 and the 5? Well, this, just kind of eyeballing it, and that's what we're doing, we're estimating. If you eyeball it, somewhere around there would be the halfway mark, so it's clearly more than half, so we would say something bigger than 10.5. 3/4 would be about there, so we're looking at an answer right around, is that closer to 10.7 or is it closer to 10.8? Or we might differ in what we would put by there, but we would, none of us would probably put 10.9. It's not that close, and it's clearly more than 10.5, so 10.6, 10.7, 10.8. I would say that that's probably pretty close to about 10.8, so I would call that 10.8. That's what I wrote there. So that is my measurement using a crude measuring device. Now let's take this better measurement device and let's see what it's going to tell us. So whenever I line it up, I again line up the 0 line right with the line, and I look at it over here. And this time I have the advantage of this actually being marked out for me in the millimeters place. Before I didn't have that. So if I look in here, this is 10.5, 10.6, 10.7, and it's not quite to the 10.8. It's between the 10.7 and the 10.8. And so if I zoom in really close on that, I can now estimate, well, how much of that red is past the 7, but not to the 8 that, and I estimate, is it halfway? Well, it looks a little more than halfway to me, so I'm going to call that, so just kind of to summarize, here we have our 10 we measured, and using this particular device, we can read off, we can look and see that it's past the 7, but not quite to the 8, so we can put a 7. Now that's a measured number. We measured that number. That's different than before. Up here, that was estimated. So it turns out that our 0.8 was a little bit too high. It's 10.7. But now, again, I always estimate one digit. So whenever I bring this over here and I kind of line it up with the very edge there, I would say that is kind of, I'd say it's well beyond the halfway mark. I'd say it's 7. I'm looking to see what digit goes after the 7. If it were halfway, I would write 10.75, because 5 is halfway between 1 and 10. And so I'm estimating how far between these two little tiny lines I think that is, and it's not easy to do, but it looks to me to be, I would say, about half. Sometimes the computer has a magnifier and you can bring out that will help you, but this one's not working today right now. So I'm going to call that, it looks a little bit past the halfway mark. I'm going to call that about 2/3 of the way. That'd be about 0.7. So it's actually 10.77, because I'd say it's about 6 or 7/10 of the way between this 0.7 and the 0.8. So this time I still have an estimated number. I always have an estimated number. This time the estimated number is in the 100th place, not the 10th place. And so if we compare these two values, the 10.77 and the 10.8, was I really off here? Well, no. If I rounded it to the 10th place, I would have the same answer in both places. So both worked, but I have a little bit more of a precise answer down here. So that's what we talk about when we talk about precision. This is a more precise answer than that. It's got a little bit more information. So if we move on to a different example, here's a beaker. We can measure not only lengths, but we can measure volumes. This is called a beaker. Beakers are really not good for measuring volumes, but we can. Here I have a little bit of liquid in the beaker, and you'll notice that there's a little curve. That curve in the beaker of the water is a result of the attraction of the water to the sides of the beaker, and it creates a little dip and that dip is what we call that a meniscus, that little dip of the water that you're seeing right in here. I mean, you could exaggerate it, but that little dip right here, that's the water there. It's the meniscus of the water. So the rule for chemistry is you always read the bottom of the meniscus. If there's a dip, you find the lowest place in the dip, and that's what you measure at. So up here, if we look here, I want to know where to measure this, so I'm going to bring my little straight edge over here, and I'm going to find the bottom of the meniscus, which is going to be about there. It's about the lowest place on the meniscus. And so again, I'm going to measure. I know that it's greater than 300. It's above the 300 line, but it's not quite, it's not really to the 400 line yet either. And so it's between 300 and 400. Now there are not little marks between there, so I really can't measure any more digits. I can only estimate one more digit. So if I look at the bottom of the meniscus there, I'd say, well, it's about halfway. So I'm going to say, well, that's about halfway between 350 and 400, 300 and 400 is 350. And so if you look at that, that is my answer. This 3 is a measured number. 5 is estimated. And this 0, neither. It's neither measured nor estimated. It's just kind of there. It's holding a place. I can't get rid of it because the answer is not 35, but it's also really not giving us any information. It's just telling us the order of magnitude of the answer. Let's go to another example. Here is here's an example of a graduated cylinder is what this is. This is actually a lot more precise. If we look at it, we can see that rather than having increments every 100 milliliters, we have increments every 1 milliliter, because we have a 40 here and a 50 here, and so there are 10 marks in between, and it's been blown up for us. And I've already got a little red line in here. So if we look here, this is 40, this is 41, this is 42, and this is 43. The 43 is right there on that line, and I've lined up the red line with the meniscus at the bottom of the meniscus, and you can see that it's pretty much right there on that. So the answer is 43, but the 43 is a measured value. We need to estimate. We can actually say exactly whether it's to the 43 or not, and we know it is to the 43, but it looks exactly on the 43, so we can't really say it's more than 43, but this is again a measured number. It's right there on our cylinder, so we can't stop there. We've got to estimate, but it's not bigger than that. But so what we're going to do, this is our estimated numbers. We're going to write 43.0. And you might say, well, what's the difference? Well, the difference is we know the difference. If we had just written 43, that would tell us that that was an estimate. This is telling us, no, this 3 is not an estimate. It's measured, and that 0.0 is an estimate. And so it's a more precise answer. If we go to our last slide here, here's an actual photograph of what this would look like if we brought our meniscus in. If we line it up here, you can see here that the 20 mark is right here, the 25 is here, so this is 21, 22, 23. So this line is at 23. This time you can see that there's a little bit of a gap between the 23 and the meniscus. So we're not going to write 23.0. We're going to write 23 point and then something bigger than 0 because it's clearly above the 23. It's nowhere near halfway between the 23 and the 25, 23 and the 24. So we're going to say, well, it's 23 point what? Well, not 0.5. It's nowhere near that. Probably not even 0.3. It's not even close to that. I would say it's 23.1 or 23.2, and we can disagree over which we put. But if we're arguing over tenths of a milliliter, we're doing pretty well, and we have made a pretty good measurement if we can agree down to the tenth of a milliliter. And so that is how you measure quantities in chemistry. You measure what your device will do, and then you make one estimated digit.